All right, so here we go. We're going to do a little bit more review with ionic or covalent. Now, the first thing you should always do is look for a metal. So let's look at our first example here. We've got aluminum bromide. Aluminum's a metal, so yes, a metal's present. That means it's ionic. So no, we don't use prefixes. So now if we name this without prefixes, we just say the name of the metal. So this is aluminum. Don't change the ending. And then you write the ending, which is the anion, which is bromine, but change the ending to bromide. So aluminum bromide. Now the next one, CO2, I don't see a metal. Carbon and oxygen are both nonmetals. So is a metal present? No. That makes it covalent. That means I have to use prefixes. So this is carbon dioxide. Use prefixes. All right, the next one, same thing. There's no metal. That means it's covalent. That means I use prefixes. The first element is nitrogen. We never use a prefix if there's only one of the first element, so nitrogen. And then there's one oxygen, so it's monoxide. Now the next one, I see sodium. That's on the left-hand side of the periodic table. That's a metal. So yes, there's a metal. That means it's ionic. And then I write the name without prefixes, no prefixes. So sodium. And then CO3, it's not carbon dioxide. CO3 is a group. We got the positive. This all must be the negative. So look up on your reference sheet, look up what this is if you don't know it. It's carbonate. ATE is your polyatomic ion, carbonate. The next one, lithium, that's a metal. That means it's ionic. That means I don't use prefixes. So I got lithium as my cation, so I write that down. That's my positive ion. And then OH, that's a group. That's my negative anion, so that's hydroxide, lithium hydroxide. Iron, iron's a metal. That means it's ionic. That means I don't use prefixes, so I write iron. Now, I know iron is in the middle of the periodic table. It's actually one of those funny guys who makes more than one charge. Iron can make a +2 or +3. The only way I know that is if I take a peek at my periodic table. This is in the box. So I have to indicate what charge it is. Now, if I realize that this is a 1-to-2 ratio, or if I uncrisscross it, let's go up here for a second. If I say, let's take that 2, put it up here, +2, and then I take the imaginary 1, put it here, -1, and I ask myself, does chlorine make a -1? Yes, it does, so that means this is correct. So this is a iron 2 charge. That's a +2, and then chloride. The Roman numerals is the charge. You have to do some work to figure out the charge. It's not how many are in the compound. All right, the next one. This is not a metal, but it should jump out at you as a polyatomic ion called ammonium. So that means it's ionic since it's an ion. This is also, SO4 is also an ion. So since it's ionic, I don't use prefixes. I just write the names of my polyatomics. Ammonium sulfate. That group should jump out at you. All right, now I look at the next one, and I see phosphorus and chlorine. Neither is a metal, so there's no metal. That means it's covalent, and yes, I have to use prefixes. There's one phosphorus, so I just write phosphorus, and then trichloride. All right, now I see dinitrogen pentoxide. Right away, I see prefixes. So yeah, there's prefixes. That means it's covalent, and if I look at the elements involved, I shouldn't see a metal, no metal. So dinitrogen, I love prefixes. They're nice and easy. That tells me there's 2 nitrogens. Pentaoxide, O5. Copper 2 nitrate, copper's a metal. Yes, there's a metal. No, there's no prefixes there. It's a metal, so it's ionic. Copper, I love Roman numerals. That tells me the charge. Nitrate is NO3 -1. Crisscross them. The 2 is going to go after the nitrate. So you put the nitrate in parentheses with a 2, and the 1 goes after the copper. I don't write anything. Sulfur dioxide. I see prefixes right away. I know that's covalent. Yes, there's prefixes. No, there's not a metal. 1 sulfur, because there's no prefix on it. Dioxide, O2. Chromium. Chromium's a metal. Yes, that's a metal. That means it's ionic. No prefixes in the name. And I see the charge. Love that. I don't even have to look at the periodic table. Chromium makes +3. Phosphate is a -3. That's a 1-to-1 ratio, so it's CrPO4. Oxygen gas. This is, you should just know oxygen obviously is a gas, but this is covalent. It's a diatomic, so there's no prefixes in the name. We just say oxygen, and it's understood it's O2. And obviously there's no metals. Now we got calcium. Calcium's a metal. Yes, it's a metal. There's no prefixes in the name. It's ionic, because there's a metal and a non-metal. And then I look and I say calcium makes +2. As soon as I know it's ionic, I know I have to deal with the ions. So figure out what they are. +2. Phosphide is -3. It's plain old P on the periodic table because it's "ide," not 8. P, -3. So then crisscross them. Ca gets the 3. The 2 goes after the phosphorus, so P2. Sodium, that's a metal. That means it's ionic. I also look at my names. There's no prefixes. Sodium +1. Nitride is normal nitrogen on the periodic table with a -3 charge. So it's Na3N. Crisscross them. All right, tetra. Right away, I see prefixes. Love them. Makes my life easy. Covalent. There's prefixes. No, there's no metals. Tetraphosphorus, that means P4. Trioxide, O3. Ammonium. That's not necessarily a metal, but it acts like a metal. That should jump out at you as a polyatomic ion. So that makes it ionic, since there's ions. There's no prefixes in the name. Another clue, it's ionic. So ammonium, you need to know, is NH4, and there's a +1 charge. Fluoride is just normal F, -1. Look at that. It's a 1-to-1 ratio, so it's just NH4F. Bromine liquid. Bromine is one of those diatomics. It's diatomics. You just have to know that. That means it's covalently bonded because it's just bromine. There's no metals, obviously, and it's Br2. Remember, you need to know your diatomic molecules. Hydrogen, and then you go over here. Nitrogen, oxygen, fluorine, chlorine, bromine, and I ran out of space, but iodine. Those are all diatomics. They're on the periodic table. There's 7 elements, and they kind of make a 7. And then you count this one, and there's 7 total. And finally, water. Water is obviously a covalently bonded structure. It does not contain a metal. It's H2O, and we don't have to worry about prefixes because water is just its common name. Its real name would be dihydrogen monoxide. Okay, so again, look for a metal. If it's a metal, it's ionic. You don't see prefixes or use them. And if you don't have a metal, it's covalent.